Okay, sixth graders, let's move on to lesson 2.1b. That's the second part of lesson 2.1. So module 2, lesson 1, and this is the B lesson. We're also going to title this greatest common factor. But if you look at this page, this is how you're going to set up the left side of your notebook for this. And you'll notice that it's different than what we've had before. Before, we've always had 6 boxes, but because of the information that I'm giving you for this section, we're going to do it differently. And you're only going to have 4 boxes. So for boxes 1 and 2, you need quite a bit of room. Box 3 is going to go all the way across the page. You don't need as much length, but you need more width. So you can, estimate and use a pencil and erase and change it if you need to. And then for box 4, you're going to need quite a bit of space because that's going to be an example. And we're only going to be doing, I think, one example in this lesson. But go ahead and set your paper up like this, and then we'll move on. Okay, in box 1, we're going to review some factoring. The first way is the way we learned about in the last section in 2.1a, which is the list method. And that's where you simply list all the factors of each number, and then you can compare them. So if you are listing factors for 6 and 12, we're going to use 6 and 12 for a lot of these examples. I would list the factors of 6 as 1 and 6 and 2 and 3. And then the factors of 12 would be 1 and 12, 2 and 6, and 3 and 4. Then the factor tree, if you recall, hopefully you've seen this before. If not, we're going to talk about it now. You take the numbers you're going to factor, in this case 6 and 12, and you create a little tree. It looks like a little tree as you go down because then you get more numbers as you go down to the bottom. So for 6, we factor that into the 2 factors that you can use to get 6. And you can use any 2 factors that you want, but the goal in a factor tree is to get down to the prime factors. That means to get down to the list of factors that have all prime numbers. And if you recall, what that means is the prime numbers are numbers that are only multiplied by 1 in themselves. So with the factor tree, we'll take 6 and we'll factor it into 2 times 3. And 2 is a prime number and 3 is a prime number, so we're done. We don't have to go any further. Once you have all prime numbers, your factor tree is done. In 12, we're going to break that up and we're going to factor it into 4 times 3. And then 3 is a prime number, so I'm just going to bring it straight down underneath the 3. And then I'm going to break 4 into its factors, which is 2 times 2. When I do that, I end up with 2 times 2 times 3. And 2 and 3 are both prime numbers, so all of my numbers at the bottom of this tree are prime, and so I'm done. So those are the 2 ways that you can factor numbers. It doesn't matter what factors you use, as long as you finish with your prime factors. So for 12, I could have done, for example, I could have taken 12, and I could have factored it as 2 times 6. 2 is prime, so I just bring it straight down, and I multiply, and I change 6 into its prime factors, which is 2 times 3. I'm still going to get the same thing if you'll notice. My prime factors still end up being the same. So it doesn't matter how you factor it out as long as you use the correct factors. Okay, in box 2, we're going to talk about finding the greatest common factor again. And we're going to really briefly review the list method. So one way is to look at the list method to list the factors of 6 and 12. In this case, the factors of 6 are 1, 2, 3, and 6. The factors of 12 are 1 and 12, 2 and 6, 3 and 4. So 1, 2, 3, 4, 6, and 12. Then I circle the factors that they have in common to find the common factors. So they have 1 in common, so I circle those. They have 2 in common, I circle those. 3 in common, I circle those, and 6 in common, and I circle those. And I did not mean to circle the 4 there, so really you really shouldn't have that part circled. That part should look more like that. Okay. So then I look at those circled factors. Those are my common factors, and I just look for the largest one. So the largest one is 6. The largest factor is 6. So my greatest common factor, or my GCF, is 6. And that's really review from the last time. Now, we talked about factor trees in the last box. Now we're going to take it a step further and learn how to find the greatest common factor using factor trees. So if I take 6 and I factor it out like I did before to 2 times 3, to its prime factors, I take 12 and I factor it out to 4 times 3, and then I factor that out to 2 times 2 times 3, so that all my factors are prime. Then I compare my prime factors for each number. So for 6, if you look, for 6 I have, looking here, I'm just going to make a little dot so you can see what I'm talking about. 6, my prime factors are 2 times 3. And then for 12, my factors are 2 times 2 times 3. And I usually put those factors in order from least to greatest when I'm comparing. Then I compare, and anything they have in common, I am going to circle, and then I'm going to multiply those common factors. But I can only multiply them once for each time that they share that factor. So, for example, 6 and 12 share 2 as a factor one time, right here. And they share 3 as a factor, right here. This 2 in the factors of 12 does not have a partner, so I'm not going to count that one when I multiply. I only count the factors that they have in common, as many times as they have them in common. So they only have 2 in common once, so I'm going to multiply 2. And they only have 3 in common once, so I'm going to multiply that one time. So 2 times 3 equals 6. And my greatest common factor is 6. And you can see that whether I use the list method or the factor tree method, I get the same greatest common factor. The list method works. However, when you get bigger numbers, more difficult problems, the list method can take a long time. It can often save time to use the factor tree method to help you find the GCF. Okay, for box number 3, this is the box that's going to go all the way across the page because you need a little more room. And I apologize that the page is blurry. I really don't know why. I tried to take the picture a few times and it still seemed to come out blurry. Okay, so I have the example here in paper, but underneath it I'm going to write it out as I explain it so you can understand it. The birthday cake or ladder method is called that because if you look at it, it looks like an upside down birthday cake with the different levels, or it looks a little bit like steps. It can be called a step method, or like ladder rungs. So if we're looking for the greatest common factor using this method, which a lot of people like because it can sometimes save you a lot of time, especially if you're dealing with bigger numbers or harder numbers, we're going to take 6 and 12, and I'm going to write them here, down here. And really, I'm writing out the same thing that I have already pre-written. I just want you to see the process that I'm doing it with. So I have 6 and 12, and I'm going to create an L shape, almost like a step, okay, or a layer of a birthday cake. And I'm going to say, okay, what factor does 6 and 12 share? It can be any factor, but a lot of times it's easiest to start with a prime factor. And one easy factor that you can always start with is, almost always, is 2. And so we're going to pull 2 out. We're going to say, okay, 2 is a factor of 6 and 12. So I take 2 out and I say, okay, 2 goes into 6 how many times? Well, it goes in 3 times, so I'm going to put the 3 underneath the 6. 2 goes into 12 6 times because 2 times 6 equals 12. Then I'm going to create another step or another layer of my cake, of my upside down birthday cake. Now, I have 3 and 6, and I have to look. Is there a number that will go into 3 and 6? If so, I need to keep going. And there is, because 3 will go into 3 and 6. So I take the 3 out, and now I say 3 goes into 3 one time. Okay, so because 3 times 1 is 3, and I put that underneath the 3. And 3 goes into 6 two times. And then I look, and I'm down to 1 and 2 are both prime numbers. There's no number that can go into 1 and 2 aside from 1, but we don't need to do 1. And so I'm finished. All right. So to find the greatest common factor, what I'm going to do is I'm going to multiply those numbers on the left of my birthday cake or ladder, not the ones underneath, just the ones on the left. So in this case, I'm going to multiply 2 times 3, because I got that from the left, and that equals 6. So my greatest common factor equals 6. Now you can write it just like I did up at the top. You don't have to make it as big as I did here. You're going to be needing to conserve space. So I just wanted you to see me working it out as we did it. But when you're finished, it should look something like at the top. Okay, so now we are at the example section. And I'm going to kind of talk you through this. I've written it ahead of time. Try to follow along with me as I go. So the example is to find the greatest common factor of 12 and 36 using all 3 methods that we learned. So the first method is the list method. I don't think I really need to talk about that much, except you list all the factors of 12, all the factors of 36. You circle the common factors, which are 1, 2, 3, 4, 6, and 12, and you take the greatest factor that they share in common, which in this case is 12. So the greatest common factor is 12. The second method is the factor tree, where you factor 12 and 36 down to its prime numbers. So, and remember, you can do that any way you want. You can use any factors to start with that you want. So for 12, I used 4 times 3. 3 is already prime, so I'm just going to bring it down. Okay, and you can see where I brought it down right here. Okay, but 4 is not prime, so I have to keep going on that one until I get it down to prime numbers. So 4 breaks down to 2 times 2. So 12, when I factor it out using prime factorization, it factors out to 2 times 2 times 3. And so I write that in order from smallest numbers to largest numbers down here where I say compare. Then if I look at 36, I took out 4 and 9 because 4 times 9 equals 36. But 4 and 9 are both composite, so I have to keep going on both of them. So 4 breaks down to 2 times 2, and 9 breaks down to 3 times 3, and then I multiply those together. So my prime factors of 36 are 2 times 2 times 3 times 3. And so I list them here to compare them. Okay, and you don't have to draw that arrow. I'm just showing you where I'm at on this paper. So I list them. Then I circle the factors that they have in common, and I'm going to multiply their common factors. But remember, I can only multiply a common, I can only multiply factors that they have in common as many times as they appear in common. So in this case, I have 12 and 36 share a prime factor of 2, another prime factor of 2 because they each had 2, 2 times 2, and then a prime factor of 3. So I'm going to multiply those common factors of those prime common factors, which would be 2, and I'm right here now, 2 times 2 times 3. I multiplied 2 times because it shows up here they share 2 as a common factor 2 times. So down here I'm going to put it in 2 times. But they only share 3 as a common factor 1 time. So I only put it in 1 time. So 2 times 2 times 3 equals 12. And the greatest common factor then, I multiply those together, and that gives me the greatest common factor, which is 12, which is the same thing I got with the list method, which should be the case. The third way is the birthday cake. So I'm right here, and I'm going to start with, if you look at the blue arrow, 12 and 36, and I'm going to create an L shape, or like an upside down birthday cake. And I'm going to take out a prime factor, which in this case is 2. 2 goes into 12 6 times, so I put the 6 underneath the 12. And 2 goes into 36 18 times, so I put 18 underneath 36. Then I keep going because 6 and 18 are composite, so I need to get down to prime numbers. So 6, 3, what goes into 6 and 18? What is a common factor of 6 and 18? And in this case, we're going to go with a prime number, so we're going to say 3. So 3 goes into 6 2 times, so I make another level, and that gives, I put 2 underneath the 6. 3 goes into 18 6 times, so I put the 6 underneath there. Then I have 2 and 6. Well, there's still something that will go into 2 and 6, and that's 2. So I'm going to pull the 2 out, and I'm going to say 2 goes into 2 1 time, which brings me down here, and 2 goes into 6 3 times. Now I'm down. 1 and 3 are prime numbers. I'm done. To find the greatest common factor, I'm going to multiply those factors that I pulled out on the left, only the ones on the left. So 2 times 3 times 2. And in this case, 2 times 3 is 6, times 2 more is 12. And so the greatest common factor is 12. So this is just 3 different ways to find the greatest common factor. You'll have to find the way that you like best, but you need to know how to do all 3. But there will probably be one that you prefer over the others. And that's really it for 2.1b. When you come to class, the right side of your notebook is going to be used for some examples, and we're also going to be showing you one more concept, but we wanted to show that to you in person. So we're going to talk about the distributive property, and so we'll be learning about that in class and adding it to your notes on your class notes page. But for now, we're done. Great job.